Welcome to example 5. Here we have a hydrogen compressor installed in a freely ventilated outdoor location. Hydrogen is a highly volatile and explosive gas that is less dense than air. Of all components in this assembly, compressor seals are at a medium to high risk of leakage, so we will base our classification design on a compressor seal leak. Let's classify this hazardous location using ExHAC. To start the hazardous area classification, we first need some information on the location. Let's create a new project. We will name this example Hydrogen Compressor Application. Altitude is 450 meters. Minimum ambient temperature is -15 degrees Celsius, and the maximum ambient temperature is 40 degrees Celsius. The location is in a compressor module within a hydrogen production facility. Next, we select the compounds involved in the release. Search for H2 in generic compounds list. Since it is already there, we don't need to create a new compound. Next, we go to FM tab and create a new mixture for hydrogen since it is not found here. Enter 100 in mole% of H2 and click Submit. Next, we go to the FM Analysis tab. Hydrogen is not listed, so let's create a new FM analysis. Select hydrogen and click on Start Analysis. The properties of hydrogen will appear on the right side. The group classification for hydrogen is a unique case. According to the IEC standards, hydrogen is in Group 2C. However, in the North American Hybrid Classification System, hydrogen may be defined as Group 2B plus H2. We will go with the Group 2B plus H2 option for this example as this is a US-based project and the Group 2B plus H2 designation will provide maximum flexibility in selecting equipment. Press Start Analysis again. And save your analysis before moving on. Now, we need to create the source of release. We will name this example compressor seal release. We expect a gas or vapor release since the flammable substance is hydrogen. We will define the gas temperature as 60 degrees Celsius and the stream operating temperature as 5,000 kilopascals. The grade of release will be secondary, and the expected ambient temperature will be 25 degrees Celsius. Press Submit, and the SOR will appear in the SOR list. Since the compressor is located outdoors in a freely ventilated location, We do not need to create a new enclosure. We can go directly to the hack analysis. Click Create Hack. Select example 5. Hydrogen FMA. Hydrogen compressor as SOR. And non-enclosed. Click Configure Analysis. Let's review the hack configuration parameters for our specific situation. The default type of release is diffusive, for a gas or vapor release. We will accept this for our application. For a suitable wind speed value for our application, let's click on the wind speed parameter, and call up table C.1 from the IEC standard. Here we see that for lighter than air releases, in both unobstructed and obstructed areas, for less than 2 meters elevation, 0.5 meters per second is a good value to use. Let's input 0.5. For a coefficient of discharge value, 0.99 is an appropriate value, given that a compressor seal is a wear item. To determine the hole size, we look at Table B1. Compressor seals are considered sealing elements on moving parts at high speed, and the hole is likely to expand due to erosion. Table B.1 recommends a value between 1 mm and 5 mm squared. Let's choose a value between these two numbers, and input 2.5 mm squared as our value. The remaining ExHAC default parameters should suffice for our analysis. Press Start Analysis, and let's look at the results. ExHAC has calculated the mass and volume release rates, as well as the release characteristic for our application. From figure C.1, we see that we fall into the medium dilution region of the chart, allowing us to designate the area surrounding the compressor as Zone 2. If we look at figure D.1, a 6.6 meter classification extent is recommended, based on the diffusive curve. This result seems reasonable, so we will approve the analysis with a note. To view our report, we go to the Hack Analysis List tab and select our hydrogen compressor application, and click on Create Report. We can view our report on screen, or create an Excel output for record-keeping purposes. The hazard zone surrounding a diffusive release will look like this. Let's apply this diagram to our compressor skid, along with our results, to show the extent on a hack diagram. Our final hack diagram will look like this. Our analysis is complete. Our hazardous area classification design, for this hydrogen compressor application, is now complete.